going to complete this chart, and we're going to look at the characteristics for linear functions and for exponential functions. Okay, so let's start. Let's just make a quick graph. So we get an idea, and everyone should have an idea of what a linear function looks like. A linear function looks like this, right? And the typical, most common, the fundamental equation is y equals mx plus b. And the main characteristic, if we were describing this verbally, is the function increases or decreases by a constant rate. Okay. So that's the main things for a linear function. Okay. Now the ones we've been exploring lately are exponential. Okay. And so exponential functions, let's just make a quick graph. Let's make one that's decreasing. It'll look something like that. Okay, and we all know the equation for this, I hope. Y equals and this one also increases or decreases. Well, let's say by a percentage, ratio, fraction, or factor. But it is going to be exponentially it's by a factor. And the factor could be a percentage, a ratio, fraction, or factor. Increases or decreases. By a percent, ratio, because sometimes they're fractions, right? Or factor. Okay. So we have a few situations here. Use the information from the chart to classify each situation as linear or exponential. So we have A through D. And then we're going to list it here. A through D is either being linear or exponential. Okay? You guys ready? Let's take a look at this first one. Let's read it together. There are 14 fruit flies in a jar, and the number of fruit flies doubles each day. Yeah, things that are doubling or halving or three-quarters, if they're a factor of something, right? You see the multiplication there. that would be exponential. So that would be here. Okay. So let's just put a little e for exponential here. Let's move on to B. So Leah has $20 and she earns $2 each week for doing her chores. Yeah, that's linear. You have an initial amount of $20 and then there's a factor u. So this would be linear. So that would be here. Okay. C. The acres of field remaining to be plowed in a farmer plows 25% of the acres each week. What do you think? Well, yeah, yeah, yeah. We got a percentage there. That's a clear giveaway. Usually, if we got a rate there like that, written as a percent, uh, we want to say that's exponential. So we'll put it here. Let's look at the last one. Marcos has 50 pieces of paper in his binder and uses 3 pages per day. Yeah, that's another linear one. You got an initial amount, that's a y-intercept, and then it's decreasing by a constant rate. So that would be D. All right. Record the letter of situations A through D next to the graph that could be used to represent it. So each of the situations is modeled by one of these graphs. So let's read the first one again. We know it's exponential. It's, yeah, there are 14 fruit flies and then the number doubles. Yeah, but which one of these graphs? Yeah, you start with 14 and then they start doubling. Right? Twice as many as the time before. So let's go with this for A. Okay. So let's move on to B. B is linear, so it's either one of these two. Leah has $20. Yeah, so which one of these? Is it the first one or the second one? Yeah, she starts with her $20 and then adds $2 more each week. Okay. Yeah. So let's just make sure it makes sense. The field remained, okay, so this one's going down, right? 25% less than the time before. So this would be C. And this one, you start with 50 pieces, and then you go down 3 sheets each time, so that would be D. Okay. So let's see. When a function is represented as a table, use the rate of change. To identify the type of function. Okay. So let's use this for what we're going to do here. Okay, you guys ready? So the y values will change by a constant. So this is for linear. For linear, it's going to change by a constant difference. So it's either increasing or decreasing, positive or negative. Over intervals of x values, the rate of change is constant as well. Sometimes we may have to simplify the fractions, but they should always be constant. All right, for exponential is going to be different. The y values will change by a common factor. Remember we were dividing them? So that was giving us a common factor. Over equal intervals of x values, the rate of change varies. It's not going to be constant. So that's going to be almost the main difference. Your rate of change is going to be always the same when you have linear. The rate of change is going to be different each time when you have exponential. Okay? So let's take a look here. Let's look at an example where it is linear. Okay? Well, let's just look at the x values. Do you see they're just increasing by 1? So they're always the same. So just plus 1. And they're always plus 1. That's pretty much going to be the case, or if not, we could just get the slope formula and divide it, and you'll get the same thing. But do you notice what's happening here? Yeah. Each time it's increasing by 5. So the rate of change, or slope, is always 5 over 1. So if we were to describe the y values changes as x values increase by 1. The y values do what? Increase by 5. I don't know but why I put plus 5 there. Plus 1 there. It should be plus 5. Yeah. Y values increase by 1. By 5. So they're constant. Over here, though, if you notice on the exponential, again, the x values are going up by 1. But here the difference is what? Well, let's just do the, yeah. Here they increase by 10. How about here? Yeah. So that's not, see, it's varying. However, if we figure out, if we take any ratio like 15 over 5, or if we do 45 over 15, 3 over 1. 135 over 45, 3 over 1. Okay, the factor is going to be the same. Okay, so again, let's describe how the y value varies, changes as the y variable increases. Yeah. Yeah. If you try to look at the difference, it varied. But the factors, the factor is 3 over 1 for, what did we say, consecutive? Y values. So that's typically what we're going to notice. The difference is going to be different. But if you take the consecutive y values and divide them, you're going to get the same thing. And that's what tells you it's exponential. Okay? Any questions? All right. So let's try these. All right. So let's see what we have here. If we have linear, exponential, or neither, let's see what we've got. Take a look at this first table. Let's decide. Linear, exponential, or neither. The x values are going up by 1. And why is it linear? Is it constant here? Actually, yeah. So we have a constant rate of change of 4. 4 over 1. Or negative 4 over 1. So we're going to say linear. How could we say it? Y decreases by 4 as, yeah, y decreases by 4 as x increases. By 1. Okay, so that would make it linear. Let's take a look at the next one. Looks like we're increasing by 1. And here, what do we got? Down by 6. Then 2. And then minus 6, minus 2, plus 2. This is neither, yeah. You should be constantly increasing or constantly decreasing, or you should be increasing or decreasing, not jumping back and forth. Possibly, yeah. But it's definitely not going to be linear, and it's definitely not going to be exponential, because you should always be going down or always be going up on the y values. Okay, so this one we're going to say neither. What's our reason? What did the y values do? Yeah, y values. Well, they did both, didn't they? They decreased and increased. Yeah, it's not fixed. The y values, I would just say increased or decreased and increased. And think about how our graphs are. They're either always going up or always decreasing. Okay. So I have a feeling this one's going to be exponential, but let's take a look. Well, if we look at our numbers, you're going down, down, down. So that's good. It's not going to be a neither. But if you look at we went down by how much? Half. Then, well, down by 80, and down by 40, then down by 20. The differences aren't linear, right? It's not constant if you subtract. But if you do something like 80 over 160, if I do 80 divided by 160, what's my common factor? What's 80 divided by 160? 1 over 2. I have a common factor of 1/2. So this one is exponential. The y values change by a factor of 1/2 of 1 over 2. right? 20 divided by 40, you get 1/2. 40 divided by 80, you get 1/2. 80 divided by 160, you get 1/2. Okay? Okay. Alrighty. So let's use our knowledge of the different types of functions to answer these questions. Okay. Tamisha determines the table below represents a linear relationship. Do you agree or disagree? Look it over. Is that going to be linear? That was quick. The y is weird. Okay, let's see what's. Well, we're going down by. We're increasing here by 3. Well, increasing by 3, then increasing by 1, and then 2. And that's not necessarily the bad part. Yeah. That's not necessarily the bad part. The x doesn't have to be consistent, but the ratios have to be the same. So here we went up by 3, right? Then by 1, and then by 2. And then over here, what did we do? So it's 3 over 3, right? 3 divided by 3 is 1. So the slope or rate of change should be 1. And then we went -7 to -4. That's 3. What's 3 over 1? 3. So here the rate is 1. Here the rate is 3. And -4 to 1 is what? And 3 over 2. So we had 3 over 3, which is 1. 3 over 1, which is 3. And then 3 over 2, which is 3 halves. We never had a constant rate of change. It has to be the same each time. So definitely disagree. The rate of change was not constant. The rate of change was not constant. We had 3 over 3, 3 over 1, and then 3 over 2. And each time it should have been the same. Okay. Tien designed a new software and 2 companies are interested in purchasing a 1-year contract. Company A offers $2,000 and will increase the amount paid monthly by $500. Company B offered Tien $800 and will double their payment each month. Okay. So I guess we have to figure out what we're going to be paid. So let's see. Here, this is Company A. They're paying $2,000 and then $2,500. You're going to add $500 each month. So after this, I have $2,500 and then $3,000. Right? You're adding $500 each time and then $3,500. Okay. It's not bad. What is Company B doing again?
Doubling.
Yeah, they're going to double this amount, right? So then we're going to double that. And then we're going to double that. Oh. Ignore that last zero. We're doubling the original amount. So 8,000, 1,600, 3,200, 6,400. Okay. Did I make a mistake somewhere? Okay. So what kind of situation do we have for this one? They want us to identify. This is linear. And so this is definitely exponential. Okay. And I would go with company B. Okay. Let's move on to number 6. The table shows the number of coffee shops in Baker City since the year 2000. Reagan says a linear function should be used to model the data. Greg says an exponential function should be used to model the data. Who's correct? And let's justify that. Well, let's see. Are we increasing constantly by we're going up by 4, 6, 9. So definitely not linear. Yeah. Is it always 2/3? 12 divided by 8?
3/2.
Yeah, it's 1.5 or 3/2. Yeah. Yeah, the fact it has a constant factor of 1.5 or 3/2. Because if you see, it's increasing but not by a constant rate. But if we do divide the factors or the y values, 12 divided by 8, 1.5, 18 divided by 12, 1.5, 27 by 8. So it definitely is Greg. Greg is correct. Increasing by a factor of, you could say 1.5 or 3/2, whichever you like. Okay. So, all right. So the last thing we're going to do is we have 3 functions and are given in the box below. You can use the calculator. Let's just quickly graph these so we can get started. The first one is linear, right? So our starting point is at 2. So we'll put a point at 2, up 3/1. So here's our first one, just a quick line. The next one is kind of what we're going to start to do after this. And that's quadratic functions. We're going to graph something called a parabola. So again, the starting point is 2. Okay. And then what I'm going to do is I'm just going to pick a value for 1. Oh, hold on. Let's finish this up. So it's going to have a point here and here because it's squaring. And then, yeah. And then at 2, it's going to be up to 6 and 6 over here. So it's going to look like this. It's going to have kind of a U shape. Yeah. It's going to take on like this U shape. This is called a parabola. Okay. All right. So now our next function, I should have done them in different colors now that I think about it. I'll do the next one in green. So this is going to cross, where is it going to cross the y-axis? At 2 again. And then 2 times 3 is 6. So this is going to be a common point. So we have this point, and at negative 1 2/3. Okay, so it should be somewhere about here. It's going to go something like this. It's going to shoot up. Oh, it's going to decrease down. Bless you. Bless you. So it's going to do one of these. It's going to come from way down in negative infinity and shoot on up and eventually overtake all of them. Okay? So we're going to identify the functions f of x. F of x is what? Linear. G of x, quadratic. And h of x, exponential. All right, so this one should hopefully be super easy. Which is going to increase most rapidly? Exponential. So h of x. Yeah. It increases and decreases the fastest all the time. All right, so that's the assignment. That's the notes. I'm going to pass out the assignment. If you would like to staple these onto your notebook.